All right, so for these multiple choice questions, we have to select two best choices. Number 32, the following are characteristics of energy. All right, so if we look at choice B, thermal energy can never be changed into mechanical energy. That's incorrect. That can be turned into mechanical energy. So B is not correct. For number C, letter C rather, mechanical energy can be changed into thermal energy. Yeah, well, we just said that it could be. So C is correct. D, energy is only present in an object when it's moving. Now, we can have energy of position or with gravitational potential energy, or if we have a spring that's compressed, that would be elastic potential energy, and it's not moving. So that's not correct. So we're going to go with A and C for the answers here. Another way to look at A, the amount of energy in an isolated system can be changed by an external force. So we know that initial energy has to equal final energy. The only way we can change this is if we add work to it, add work or take work away. All right, number 33. When analyzing work and energy problems, When analyzing work and energy problems, it is important to define the system and the environment in such a way as to make the problems easier to solve. The following are characteristics of a system. Forces internal to the system, let's look at A. Forces internal to the system can change its total mechanical energy. That's incorrect. We know from Newton's third law that those forces are equal and opposite to one another. A system can be one object or a collection of objects. That's true. We can have more than one object. The system is external to the system boundary. That's incorrect. The system is found inside of the boundary. Objects cannot pass through the system boundary. We don't want the objects passing through so that we have a total system here. So B and D look accurate. All right, number 34, a constant force, F, is applied to a block sitting on a bench. There could be other forces acting on the block at the same time. In which of the following cases is no work done on the block by a force? So we know work is equal to force times displacement, and it needs to be parallel. So the force is applied to the block and it moves in the same direction. That's going to be positive work. That's work done. Force is applied to the block and the block moves in the opposite direction of the force. Well, yeah, that's going to be a negative work, which is fine. The block does not move. Well, if there's no displacement, there's no work. So C would be obvious choice. The force is applied perpendicular to the block. Yeah, the force has to be, again, it has to be parallel to the block's motion. So C and D are your best choices. Number 35, a student swings a ball around his head in a perfectly circular horizontal orbit with constant tension. Which of the following is true concerning the ball's orbit? A, no work is done by the tension force since the force is perpendicular to the ball's motion. Well, when it's in circular motion, yeah, the force is directed toward the center, and the ball's motion is tangential to the circle, so they are perpendicular, so no work is done. That's true. The ball maintains a constant speed. Well, if it's in orbit with constant tension, it would need to maintain a constant speed. The ball maintains a constant velocity. No, the velocity is constantly changing direction. That's the definition of circular motion, so C is incorrect. The ball speed increases due to the work done by the tension force. No, the tension force is a constant tension. That's incorrect. So A and B are your best bets.